In this video, we will discuss functions and some of their related properties. So a function is a rule that assigns to each object x and one starting set, something we call the domain, a single value f of x from a second set. And the fact that it assigns each input exactly one output is the defining characteristic of a function. The set of those outputs is called the range of the function. And let me give a couple graphical representations of functions. So what we can think a function of as being is, you start off with, one set, your domain, and you have a function f. It maps to the other set, the range, all possible outputs. And for every, input, I'm just going to draw kind of three dots. We have, some output over in the range. And the key thing is that that input can only go to one output. So since I have one arrow starting at that top point, I can't draw an arrow over to the other point. But I could have that other function mapping to the same point. So every input gets exactly one output. But that doesn't mean every output cannot have corresponding multiple inputs. From a more graphical perspective, something that we've encountered is f of x equals x squared. Its graph is this parabola opening upward with the vertex sitting at the origin. So the domain of the function is where we're getting our inputs. What does it make sense to plug into the function? Well, we can plug anything into a squaring function, so minus infinity to infinity. And the range is made up of all possible outputs of the function. So we think of that along the y-axis here. We see all possible outputs are from 0 and to infinity. So let's look at just some basic function evaluations. For the function x squared minus 2x, let's find and simplify the following quantities. So f of 4. Well, one of my favorite ways of thinking about a function is to change that independent variable x, it's just representing what we're plugging in, to be a blank box. And think of this as f of something is that something squared minus 2 times that something. So f of 4, the something I'm plugging in is 4. So 4 squared minus 2 times 4, 16 minus 8, which is 8. Similarly here, f of 1/2. We're plugging 1/2 in for our something. 1/2 squared is 1/2 times 1/2, which is 1/4. Minus 2 times 1/2 is minus 1, and this ends up being minus 3/4. So let's look at something just a touch different. F of 4 plus h. What we're plugging into our function, this blank box, is 4 plus h. So this will be 4 plus h is going to that first blank box, it's squared, minus 2 times 4 plus h. So let's go ahead and expand out. 4 plus h quantity squared is 16 plus 8h plus h squared. And then what we're subtracting away, we can go ahead and distribute that minus 2 to both terms. So minus 8 minus 2h. Now combining all of our like terms, this becomes an h squared, 6h, and 16 minus 8 is a positive 8. Now the last part here, d, is something that we will encounter frequently throughout calculus. This expression is something that we will later on call a difference quotient. But let's go ahead and combine our work from above and just simplify down to see what we get. So f of 4 plus h we saw in part C is h squared plus 6h plus 8. We're subtracting away f of 4, which we saw in part A is the number 8. And this is all over h. Plus 8 minus 8 cancels. And in the numerator, we can factor out an h. And since we're dividing by h, the h's cancel. And the simplified version here is h plus 6. So as I mentioned in the previous example, finding this thing that I called the difference quotient is going to be very important once we get to the calculus. So let's go ahead and find it again for this function 10x plus 3. And let's just go ahead and do this all at once. So recall I said my favorite way of thinking about a function when I have to do these evaluations is to replace the x with just a blank. And whatever we plug into our function in one blank has to go into all of the others. So f of x plus h will be 10 times x plus h plus 3. Then we are subtracting away f of x, so that would be 10x plus 3, and dividing by h. Now we simplify. So distributing the 10 in the first term in the top, 10x plus 10h plus 3. And now we have to be very careful. This minus sign has to be distributed through. A very common mistake is not correctly distributing. So minus 10x minus 3 all over h. And noticing in the top we have a positive 10x, a minus 10x. Positive 3, minus 3. What's left in the top is a 10h, and we're dividing by h. So all that we have left is a 10.